Now, having seen the intuition behind binary search, let us write the code to implement it. So I get on, let's say, writing a function called, say, binary search, and I give two arguments, L and X. L is a list, X is the value that I'm searching. So I just put a small comment here, binary search on list L for value X. So I'm looking for X in L, but we will do it with binary search, right? So I start with a Boolean variable called found. I set it to false, false here. So Boolean variable found is false. Now remember, the whole idea is that I'm going to set two pointers, one low, one high, and I'm going to search in the middle of those two. So I'm going to say, well, low is equal to 0, high is equal to, say, len of L minus 1. Now, I will search in the middle, but the search has to go on until I find the item or I find that the item is not in the list. So to cover both of these conditions, I put a while loop. I just go and say while not found and low is less than equal to high. We will come back to, let's say, understanding a little bit more detail why low is less than equal to high is important. But for now, let's just take it that way. The moment these, while these conditions are correct, while these conditions are true, I just find the mid pointer, and that is given by low plus high floor division by 2. Now, once again, we will look at why floor division, but you get the idea that I'm looking at approximately the average of high and low, which is basically going right in the middle of the high and low. So the midpoint is where I'm going. That is where I search. So I just go and say found is equal to X, let's say is equal to L mid. So I look at the midpoint item. If that is equal to X, well and good, I've already found my item. If, however, item is not found, so if item is not found, I just ask myself, well, if let's say X is less than L mid, which means the value that I was looking for is smaller than what I am presently finding. Okay, so there has to be a colon over here. If this is the case, well, I'm going to adjust the high pointer to mid minus 1. Now, again, we will talk about why mid minus 1, but you get the idea that, the number was too large, so I can discard everything on the right of this number, which means the second half of the list can be completely discarded. I move my high pointer to, let's say, mid minus 1. Else, which is a situation where X is more than L of mid, well, in that case, I know that the value being searched is on the right side of the mid, so I can move my low pointer to mid, say mid plus 1. Now we'll talk about why mid minus 1, mid plus 1, and so on. But for now, this is logical. I can just go and say, once the while loop exits, if I have found this item, well, very good, return, say, mid. Else, return, say, return minus 1. Now, that's pretty much it, because if I don't find the item, I just return a minus 1. Let me just run this, and then we can do a very quick test on this. Let's say I add a new code cell, and I just go and say binary search, let's say binary search for, say, in a list, say, range 100. So 0 to, say, 99. If I want to search for, say, 43, when I run this, indeed the answer is 43 as I had expected. But if I were to search for 143, you realize that answer is minus 1, because indeed 143 is not a part of this list. Now like I said, we are going to look at this code much more carefully as we move forward. But before wrapping this up, I just want to highlight 2 points here. Number one, the search always happens on the mid pointer location. Now remember, we have a high pointer, we have a low pointer, but the search is always happening on the middle pointer. And we saw this in the code. Found was equal to X becoming equal to L mid. So we are searching in the middle location. That's important. Number two, the while loop runs while this condition is true. Now this condition is quite interesting. It says while not found and low less than equal to high. Now remember, while loop runs while the condition is true, which means anything that makes this entire condition false will make the while loop to exit. Now that happens in two situations. Remember, this is an AND over here, so this becomes an OR. What we are trying to say is that, look, in either of these conditions, which is found becoming true, which means I found the number, or low becoming more than high, if either of these two happen, then I exit the loop. Now what does low greater than high mean? Well, that means that the pointers invert. So remember, my high started being the end of the list, low was the start of the list. But if at some point in the iteration I find that low has gone to the right side of high, Well, I'm going to exit because that tells me the item has not been found. Think through this: low less than equal to high. The inverse of that is low greater than high, because this less than equal to means, it can be less than or it can be equal to. Greater than exactly is the reverse of that, right? Now, like I said, we are going to look at all of this more carefully with some examples and, let's say, illustrations, so that this becomes clear. But these are two important points about the code at this point of time. We'll come back and analyze this with several examples in the subsequent videos. I hope you found this interesting. Do look at our website www.ybyte.in for more such content, and enjoy programming. Take care. Thank you so much. Bye bye.